So sort of picking up right where we left off last time, we sort of ended with this this absolute value function here, and this -4 absolute value of x plus 2 minus 7. And we talked about just from looking at the numbers and sort of knowing what the numbers do, we can analyze what sort of transformations are going to be happening to something, right? We know that there's going to be a horizontal shift 2 units to the left because of this plus 2 here. Remember, what happens inside of the parentheses is in the x direction, and it's plus 2 because plus 2 corresponds to a shift to the left because it's sort of the opposite of what you'd expect. You need smaller x values to get the same y values back, so it's a shift to the left. Horizontal shift is 7 down because of the -7 here. This 4 corresponds to a stretch. It's a stretch because it's a number bigger than 1, and it's by a factor of 4, so all my y values are going to get quadrupled. And then the negative reflects it, so it flips it over the x-axis. Okay, so all 4 of the transformations that we've talked about are sort of represented in this one equation. The question becomes like, what are we transforming? Like what actual, these are the things that are going to happen to some graph, but what graph is it, right? And this sort of forces us to think about what we call a parent function, okay? And in this case, the parent function is just going to be y equals absolute value of x, okay? A parent function is sort of like the like main heavy lifter of the math, right? It's not addition or subtraction or multiplication. It's not like the core arithmetic that everybody knows since 3rd or 4th grade. It's like the actual like beefy part of it, right? In this case, the absolute value is what's doing most of the work. And that's sort of what we're going to start with and what we're going to apply these transformations to. So we could, just to back up a little bit, we could just make a table of values for this function, right? For this one right here, we could just start plugging in numbers. But that's a little bit of work to plug in that many numbers. And it's actually a lot easier to make a table of values for this new parent function that I have written in purple, right? So if we can make that table and then do the transformations, it actually ends up going a little bit faster after you've done it a couple of times for practice, right? But this table is easy, right? The table for absolute value is nothing at all. If I plug in values of x and I solve for y, well, any positive value of x is just going to give me the same exact value out for y. Any negative value of x is going to give me the opposite value out for y. So let's go counting down. -3, -2, -1 would give me 3, 2, and 1. And then, of course, 0 for x gives me 0 for y. Okay? I made that table in like a split second because really it's just, you know, if x is negative, y becomes positive. If x is positive, y stays positive, and then 0, 0. And I can plot those points, again, very quickly. So I have 0, 0, I have 1, 1, I have 2, 2, I have 3, 3, and then, of course, the negative x's with positive y's, and we get this familiar V shape, right? And we can draw that V shape in like, I don't know how long it took me exactly, but it only took me a matter of seconds, okay? And it's not a perfect straight line, but it's close enough to give me the rough idea of the shape of the graph. Once I have the parent function, now we can do exactly what we were doing to sort of the generic f of x's before, where we take these key points, these well, I did 7, but we really only need 5 of them. Probably in this case we only really need 3 of them, but I did 7, so I'll do it for all 7 of them, and apply these transformations in the appropriate order. Now remember, the order goes based on order of operations, so the vertical shift is going to be the first thing that we do, or I'm sorry, the horizontal shift is going to be the first thing that we do. The vertical stretch will be second, because the next thing I would do after the inside of these, they're not parentheses, but the inside of the absolute value bar, the next thing I would do would be the multiplication, right? And then this negative sign is also multiplication, so we'll do that third. It doesn't really matter what order you do the stretches and the reflections, but the vertical shift has to go last, so that will be 4th. Okay? So point by point, I'm going to move it 2 spaces to the left, then I'm going to stretch it by a factor of 4, then I'm going to reflect it over the x-axis, and then I'm going to shift it 7 units down. So let's start with the point at 0, 0. If I moved it 2 spaces to the left, it would be here, okay, at -2, 0. Of course, it's not where it's going to end up, but that's sort of the first step. Stretching it by a factor of 4, remember that's multiplying the y coordinate. The y coordinate is 0, so 0 times 4 is 0. And reflecting it does nothing as well, right? Because reflecting it over the x-axis, well, it's already living on the x-axis. So then the only thing I have left to do is move it down 7 spaces. So 1, 2, 3, 4, 5, 6, 7. This is where it ends up. Okay, so again, just to recap what I did there, I took this point 0, 0. Whoops, hold on. Oh my goodness. How did that happen? What did I do? Oh, okay, good. Whew, that was close. I took this point at 0, 0, right? Now I'm erasing. This video is off the rails. Okay, I took this point at 0, 0. I moved it 2 spaces to the left, pop, pop. I reflected it and stretched it, but that didn't do anything because the y value was already 0. And then I moved it 7 spaces down. Took me to right there. Okay, so that's the first point. Let's do the exact same process with another point. Let's do this point right here. Okay, I'm going to move that point 2 spaces to the left first. So 1, 2 spaces to the left will put it right on top of this other point. Now I'm going to stretch it by a factor of 4, which means the x value is not going to change, but the y value is going to get 4 times bigger, right? Because it's multiplication. I'm going to multiply the y value by 4. So it used to be 1. Now the y value is going to be positive 4, which will put me up 1, 2, 3, 4 right there, right? Multiplied by 4. Now I reflect it over the x-axis, which puts me at -4, so same x value, but now I'm at -4, so I'm down there. And then I move 7 spaces down, so 1, 2, 3, 4, 5, 6, 7. Okay, and that's good. So I moved 2 spaces to the left, multiplied the y value by 4, flipped it over the x-axis, and then I moved 7 spaces down, and it ended up right there. Now, if I try to do the same thing with this one, I can already tell it's going to go off the bottom, right? Because I'm sort of already at the bottom here. So let's do this point instead. Let's do -1, 1. 2 spaces to the left would put me here. Quadruple that y value because of the 4 times. So it's going to become -3 up 1, 2, 3, 4 up there. Reflect it over the x-axis. 1, 2, 3, 4 puts it right there. And then move it 7 spaces down. 1, 2, 3, 4, 5, 6, 7. Okay, erase all my little intermediate markings just so that it's nice and clean. And connect the dots. Notice it's still going to be sort of a V shape. The shape doesn't really change other than the fact that it's stretched now, right? So it's skinnier than it used to be and taller than it used to be. But it certainly got flipped upside down, which is what I expected. Looks like it moved over and down, which is what I expected. So great. There it is. There's my graph, right? So all I really needed to do this was a parent function, which was absolute value in this case, and transformations, and I drew the graph. It took me quite a bit of time, honestly, but it would go a lot faster if you sort of practiced it a couple of times and weren't explaining it and stuff like that. It also resolves the issue of like, what number do I plug in? Because, for example, if I plug a 0 in here, I'm going to end up with a -15, and that's going to be off the bottom of my graph. So that was another issue we ran into when we tried to draw a graph by plotting points, is we never really knew what numbers would actually work. Now we do. Now we know exactly which numbers work because we're just transforming points that we drew already on one that always fits on the graph, which was just the parent function, right? So yeah, that looks good. Also, I want to call your attention to like this point right here, which we call the vertex. The vertex is -2, -7, right? You can kind of see that from transformations alone, right? Because I moved 2 spaces to the left and 7 spaces down. So it's actually really easy to draw where the vertex is going to be because the vertex goes from 0, 0. So yeah, kind of nice. I don't know. Let's do another example with a different parent function this time. So now I have this, right? So let's see what we got here. I see some errors already because whoever wrote this, well, it was me, but I wrote it in kind of a rush. So I definitely see a horizontal shift, but it's not going to be to the left. It's going to be to the right. Let's fix it. 1 unit to the right. Okay, because remember, if I'm subtracting 1, that means my x values has to be 1 units bigger to get the same y value, so it's going to move 1 unit to the right. Okay, this +3 is going to shift it 3 units up. This vertical shrink is going to be by a factor of 1/2. It's a shrink because it's a fraction less than 1, and there is no reflection. There's no negative signs anywhere to be seen. So good enough. I only have 3 transformations to worry about here. It's a little less work. First thing I want to think about is what the parent function is. In this case, the most mathematical work, like the heavy lifting, is this square here, right? The rest of it's all the transformations, the multiplying, the adding and subtracting, anything that's not already a transformation, that's what I'm going to call my parent function. And conveniently, that function's really easy to plot points for, right? Because I know, like, if I do 0, I get 0. If I do 1, I get 1. If I do 2, I get 4. If I do 3, I get 9. I'm just squaring, right? I'm just squaring numbers. That's not too bad. I can do it in my head. Negative numbers are going to give me the same numbers back. -1's going to give me +1. -2 is going to give me +4. I would even do -3 would give me +9. And then 4 would give me 16. And -4 would give me 16. So these points are easy to plot. This graph is easy to draw. compared to this graph, which has a lot of mathematical heavy lifting involved, right? So, okay, I have 0, 0, 1, 1, negative 1, 1. I have 2, 4, 1, 2, 3, 4, and negative 2, 4. I have 3, 9, so 5, 6, 7, 8, 9, and negative 3, 9. So yeah, it's our famous parabola shape, which I drew so well. Oh my goodness. Yuck. But good enough for a sketch. Now that I have all these key points, all I need to do is move them around, right? Shift them, reflect them. Well, no reflection. Shift them and stretch them, and that's about it, right? So the first thing I'm going to do is the horizontal shift. Then I'm going to do the vertical shrink. Then I'm going to do the vertical shift. In that order, because of order of operations, I start on the inside and I work my way out. -1 comes first, then times 1/2, then +3. So let's start with the point 0, 0. The horizontal shift is going to put me here. Shrinking it by a factor of 1/2, well, 0 times 1/2 is 0, so that doesn't move it at all. And then I'm going to move 3 units up. 1, 2, 3 puts me right there. Okay. Good enough. Let's do the point 1, 1. This is going to be a little tough because when I shrink it, it's going to end up being 1/2, but we can do it. Move it over 1 unit puts me there. Now I have to apply the shrink. Well, 1/2 of 1 is 1/2, so that kind of puts me in between the two boxes, right? So it's at positive 1/2, and then I go up 3 units, so I'm going to end up at 3 1/2. So 1, 2, 3. I'm kind of right there. Okay. A little awkward because of the 1/2, but I managed to draw it, so that's good enough. This guy, same thing. 1 unit to the right puts me there. Shrink it by a factor of 1/2, so now it's sort of at positive 1/2, and move it up 3 units. 1, 2, 3 units puts me right there at 3 1/2. Right, and it's not great. I'm kind of ballparking it. But these guys are going to be a lot easier to draw. So like, for example, this point here, which was at 2, 4, this one, right? I'm going to move it 1 unit to the right, puts me there. Now, instead of the y value being 4, when I apply the shrink, the y value is going to become 2, right? So that would put me there. And then finally, I'm going to move it up 3 units. So 1, 2, 3 puts me right there. Okay, so that point got translated 1 unit to the right, chopped in half as far as the y coordinate goes, and then shifted 3 units up. Puts me right there. Let's move this guy. Whoops. Eraser. Back to my green pen. Here it is. Let's move this guy. I'm going to move him 1 unit. Oh, wait, it was a red pen. 1 unit to the right. Put it there. Chop that y value in half. It was 4. Now it's going to be 2. And then move 3 units up. 1, 2, 3. Puts me at a final position of 5. Okay. And already I can kind of already see how my graph is shaping up to look, but might as well draw these points as well. Again, they're going to be fractions because that y value is 9. So when I move a 1 unit to the right, it'd be here. And now my new y value instead of 9 is going to be 4 1/2 because half of 9 is 4 1/2. So 1, 2, 3, 4 1/2. That would put it right there. And then move it up 3 units. 1, 2, 3. There's its final position. Okay. A little sketchy because it's in between 2 boxes. But we got it done. Same thing over here. 1 unit to the right becomes 4 1/2. So 1, 2, 3, 4 1/2 will be right there. And then 3 units up. 1, 2, 3. There's its final position. Okay, so with all of these points, I can kind of already see what my graph is going to look like. It's a much fatter parabola, right? Kind of squattier. It got like squished down. If you put your hand on top and on the bottom, you could squish it. Again, I do want to call attention to the fact that like this vertex point is 1, 3, which you can see from right here. 1, 3. Okay. But that's function transformations in a nutshell. It's really just a matter of drawing the parent function correctly, right? So just plotting 5 points, 6 points, 7 points sometimes, and then moving them around, right? Based on the rules of the transformations that you can identify. So if you're good at identifying transformations and you're good at drawing parent functions, you're sort of 2 steps of the way in, and the last step is really just applying those transformations. Alrighty, cool. That's about all I have to say. I don't really have any other examples, but we'll practice some more next time I see you guys in class. So until then, yeah, that's about it for me. See you later.